Robert, we've been talking about clean code, and you mentioned that duplication is a key enemy. Can you give us some concrete examples?
Absolutely. Imagine a system that has to scale images and rotate them. If the code for both of these operations looks nearly identical, that's duplication. We need to find a way to combine these operations.
That makes sense. How do we detect and address this in more complex code bases?
One good approach is to identify the common steps. In your scaling and rotating example, the core operation is updating the image. That's something we can extract as a reusable part of the code.
So you're advocating extracting a method?
Exactly. And you'll often find this is a step towards following the single responsibility principle. This might reveal new opportunities for even further abstraction.
So you're saying we shouldn't be afraid to introduce some intermediary functions to make our code more reusable?
Not necessarily more functions, but strategically factoring out common elements into their own, more generalized methods. This is where patterns, like the template method pattern, come in handy.
This template method pattern? Can you elaborate?
Sure. It's about establishing a method, like a crew vacation, with specific steps: calculate, adjust, and apply. Subclasses, like US vacation policy and EU vacation policy, override the part that's specific to the legal framework.
Makes perfect sense. So, you're saying variations are handled in subclasses?
Yes, that's the elegance. One core method, with variations controlled via subclasses. It keeps the core logic clean and reduces duplicated code, making maintenance simpler.
So, when is it okay to refactor, and how much is too much?
It's a judgment call. If you're making small changes to improve readability and maintainability, it's generally a good thing. If it's huge, consider the time investment and the risk of introducing bugs during refactoring.
It seems like a delicate balancing act.
It is. But clean code is worth the effort, isn't it? Making systems more maintainable saves time and resources in the long run.
Definitely. Thanks, Robert.
You're welcome.
So, Robert, we've talked about why clean code is important. Now, how do we actually make code expressive?
Well, Andrew, expressiveness boils down to making your code readable. It's about writing code that clearly reflects your intent.
Okay, so choosing good names is key, right?
Exactly. Think about it. A function called calculate total price is much clearer than something like X.
That makes sense. But how small is small for a function?
There's no magic number. A good rule of thumb is, if a function does more than one thing, or is over 10 lines, consider breaking it into smaller functions.
So, breaking down large functions into smaller, more focused ones helps a lot?
Absolutely. It's like building with Lego blocks, you know? Each block does one thing. Much easier to see the whole structure.
I see. In design patterns?
Yep. Using standard pattern names, like command or visitor, in your class names gives others a heads up about what's going on.
That helps with comprehension, right?
It does. Makes it easier to connect the code to its design.
Sounds like a lot of thought has to be put into the code right away.
It's not just the naming. Unit tests act like living documentation.
Interesting. How so?
They show examples of how your code is supposed to behave, making it clearer what it's supposed to do.
Wow, a lot of detail to keep track of.
Precisely. Care is a precious resource. Taking the time to do it right pays off big time.
So, you're saying writing clean code takes time and effort?
You bet. But the investment in expressiveness dramatically reduces long-term maintenance headaches.
That's very insightful. So, it's a good investment of time.
Absolutely. And remember, you are the most likely person to have to modify that code in the future.
Right? Makes total sense.
Keep those functions and classes small, choose meaningful names, and use standard patterns.
Perfect. I'll take note of everything you've said. Thank you, Robert. So, Robert, you're saying we shouldn't obsess over teeny-tiny classes and methods?
Exactly. It's easy to get caught up in the idea of minimalism.
But aren't smaller classes and methods better for maintainability?
Yes, generally. But sometimes we go too far. Sometimes breaking things into too many small pieces actually makes it more difficult to understand and work with. Like, imagine creating an interface for every single class. It looks minimalist, but it complicates the entire system.
So, how do we know when we've gone too far? How much is too much in terms of classes and methods?
There's no magic number. It's about the reason. Are you eliminating duplication, improving code expressiveness, or are you just blindly following a rule?
Right. Like a rigid coding standard saying, always separate data and behavior into separate classes. That can become a hindrance.
Precisely. Pragmatism comes into play. Think about the context. A small function can improve readability, but if it's just to hit an arbitrary class/method count, it's probably pointless.
Makes sense. So, it's about the balance?
Exactly. Like building a house. You want strong foundations, but you don't need a mile-long foundation. We need to prioritize things like tests, making the code easier to read, and eliminating code duplication.
So, you're saying that a larger, well-structured class, even if it's longer than the rule dictates, can be more valuable?
Absolutely. If a large function encapsulates a significant and well-defined task, there's no issue. That's how solid principles are useful.
That's a great point. Thanks for clarifying that.
My pleasure. Simplicity's a goal, not a dogma.
So, Robert, you're saying these simple design practices, while invaluable, can't fully replace the years of experience under someone's belt, right?
Precisely. It's like learning to play a musical instrument. You can learn the notes and scales, but experience gives you that nuance, that feel, that intuition.
So, you mean understanding when to apply these practices rather than how to apply them?
It's both, Andrew. You learn how quickly, but experience helps you recognize the specific nuances of a problem. You get that gut feeling for what works and when.
What do you mean by simple design practices?
Think about solid principles, dry principles. Those are patterns. They're useful tools, but you need experience to know which tool to use when.
But if I follow these practices meticulously, how can I develop that experience faster?
Following the principles helps you build up a solid foundation. The patterns teach you to write readable and maintainable code, crucial for future projects and collaboration.
I see. You're saying experience is like knowing how to use these tools effectively in a real-world scenario?
Exactly. Applying dry to, say, refactor large codebases requires an intuition built over years of practice. These simple patterns are like a pre-built framework for that.
You mentioned crystallized experience. Can you give an example?
Well, consider robust error handling. A simple pattern here might be to use try-catch blocks. But experience shows you when to log the error, what context to gather to properly diagnose issues, and how to prevent them from recurring.
So, the practices lay the foundation, but experience is the actual building?
Yes, the practices lay the foundation. Experience builds the structure, and understanding builds the design. Experience helps us know when to optimize, and when to prioritize clean code.
That makes sense. Thanks, Robert. It really clarifies things.
My pleasure. The key is to combine these practices with real-world problem-solving.
Interesting. So, I could, with focus on practice, learn to write clean code better, faster?
Exactly. You're not just building code, you're building a skill set.